Hello everyone. Today I want to discuss about one important topic, uh, which you may know. This is chromatography. The chromatography is a separation process. The chromatography can be different types like gas chromatography, high performance liquid chromatography, etc. In this video, I'll discuss about gas chromatography. So in the gas chromatography, we have to know mainly three things. The first one is the phase. In the chromatography, there is two type of phase. One is mobile phase, which is moving, and one is stationary phase, which does not move. So in the mobile phase, you can see the gas. Usually, it's the gas medium like the inert gas, argon or helium like that one. In the stationary phase, we can see it can be two types like liquid and it can be like solid. So basically, if we classify this chromatographic process, it can be gas liquid chromatography or gas solid chromatography. So next thing is the characteristics. So basically, it's a separation process, and we have to find out the organic compounds, which compound is what. That is why we use this gas chromatography process. So this is process actually happens into two characteristics, like the one is the volatility, another is the polarity. So I hope everyone knows about this volatility and polarity issues. Okay. Then next thing is the mechanism. So here there is a column by which we have to detect the moving compound. So it's mainly happens in the stationary phase column, the separation process. So if we want to see the mechanism and all the data and basic principle, how it works, then you can see the mobile phase, which is the gaseous phase of inert gas, and mobile, it will take the sample to the detector. So this mobile phase, the inert gas is used, and there is a sample injection chamber. So where we have to keep the samples in vials, and these samples, it will not go immediately. That's why we need to heat at very high temperature. So when we will heat at very high temperature, it will turn into vapor, and this vapor will move to a big column. So in this column, so the inert gas or the mobile phase, it will take the sample vapor to the detector through the column. So finally, in the detector, it will detect and will get our data in the computer. I don't want to make this video big. I just telling you the basic principle of these ones. So the time that takes to take this molecule to the detector, it's called retention time. So according to the retention time, we can find out our organic compounds, which compound we are detecting. So for example, we have three compound like A, B, C. A comes first, B second, C third. So it can be classified as like this. A has higher volatility. So it goes first, B is second, and C is third. So according to the volatility, we can classify like this. And the column, it can be two types like packed column and the capillary column. Hmm. So if we want to know more details, then I can say, for example, we have three compounds, A, B, and C. A is the most volatile non-polar. B is polar but volatile. And C is medium volatile but polar. Okay. So for example, this column can be 3 to 6 feet. In this column, if we say the column is polar, so if the molecules which are going, that is also polar, so it will react with the polar compounds and it will hold those compounds. So it will go last. For example, we have A, B, C, three compound. First one I say most volatile. As I already said, the most volatile will go first and the less volatile will go last. So A is most volatile and non-polar. Non-polar means it will not react with the column, because I already said the column is polar. So non-polar compound will not react with the polar compounds. So it will not hold it. So A will go first. Let's see about B. B, I said polar volatile. So it is volatile, but it's polar. So polar, it will react, so it will hold and it will go last. But if you see C, which is mid level volatile plus polar, that means it's polar, but it's a medium volatile. So it's more volatile than the B. So C will go second. Finally, the B will go. So in the graph, if you see, there is y-axis can be signal and x-axis can be time. So we can get two type of peaks for A and B. So this B, which has high peak area, that means high concentration. A has less peak area, that means low concentration. So according to the peak area, we can also determine the concentration of the compound. So in this GC gas chromatographic process, we can get high quantitative data. But in modern technology now, also the mass spectrophotometer is connected with the GC. So in the pharmaceutical industry and other testing lab, so GCMS are used. But if I say it has still some disadvantage, like it only detect the volatile compounds. So for other compounds, it doesn't give high quality quantitative data. So I hope everyone understand. Uh, so one thing I also forget, this column, these compounds are going. So there needs to be a pressure which will be done by the pump, so that the compounds will go to the detector. Okay. Thank you.